Hi, welcome back. In this video, I'll be showing you a ton of math features which you can use in Kotlin. So let's start with defining some standard variables like pi. We can invoke a pi value by adding math.pi. It's as simple as that. And then similarly, we also have another constant at our disposal by invoking it by saying math.e. These are common variables which you may use in your projects depending on what you're working on. So these are the constants which we have. Now let's start with our functions. So the first function I would like to show you is the absolute function because I find that to be absolutely valuable in most of my projects. So let's start with that. So you invoke this by saying math.abs, abs which stands for absolute. So we try this out by, let's say, adding a negative number. So the main function of an absolute function is to convert a negative number into a positive number just by removing the minus sign. So let's see this in action. So let's go ahead and print that out. I'll actually change this to absolute function. Let's go ahead and do that. As you've changed, the sign has been changed to -5 from 5. Now let's add that back. The next function I'd like to show you is the Ceil function. So the Ceil function basically tells you how to change a variable from a value to the next possible integer value, the higher integer value. So let me illustrate this with an example. Ceil, let's say 19.9. So what this does is it converts this 19.9, which is a fraction, to the next possible integer. So let me go ahead and print that. So it's going to change it from 19.9 to 20.0, as you can see here. So you can think about Ceil as the ceiling. Ceiling, you look at it from bottom to top. So it's shifting from the current value to the next possible integer value. Similarly, let's try something called floor. So use floor when you'd like to reverse this behavior. So if you have a 19.9, you would like to change it to a 19.0. Let's try this out. As you see here, we have a 19.0. Now let's go ahead and have a look at another kind of function called the max function. This also comes in handy so many times. If it wasn't for this function, you would have to implement a set of few boilerplate codes in order to emulate it. So I find this handy many times. So this is how you implement it. You just call math.max and then you enter in your two numbers. So this takes in an argument of integer, long, float, or double, which makes it ultra handy. So let's take an example of 10.2, 10.3. So here the maximum variable between these two is 10.3. So max is going to take in the value of 10.3. Let's go ahead and check if that works. As you can see here, we have 10.3. Now similarly, let's try min. So in order to try this, we would need to, let's just maintain the same variables, and in this case we would be getting 10.2 in our variable min. I'm going to print min out and let's see what we get. Yes, as we've assumed, it is 10.2. Now we have an interesting function in Kotlin. Even though you may not find its use, I still find it pretty interesting. However, I would personally not use it. So this function is the decrement function. So Kotlin, unlike many languages, has a unique function which is to do something very simple, but I guess you could change to this behavior if you find it useful. Decrement exact. So what this does is it takes an integer or a long and then it keeps decreasing it by 1. So this is exactly the same as 10 minus 1, or to be more precise, this. But then what this allows you to do is it does not allow you to invoke the same variable here, which could make it handy at times, but you usually decrement a value which has already been initialized before. So let me just go ahead and change that back. So what we are intending to get here is the value 9, which is 10 minus 1. If it were 9, it would be 9 minus 1, which would be 8. Let's revert back, and then let's try the decremented value. Let's go ahead and hit run. And as we expected, we have a 9 here. Let me try with 10.0. Sorry, let's try something large. As you see, you have 1 which is being removed out of this. So similarly, let's try increment value. So that's increment exact. Let's try a smaller number, 1. This should yield us 2. As you see, we've gotten 2. Now, the next one I'd like to show you is a really handy function, which is called square root. Like many other languages, it's just math.sqrt, and then enter in the number which you'd like to find the square root of. I'd say a standard 4 would do. So this takes in the parameter of a double, so that's why you have to add a 0.0 to signify that it's a double and not an integer. Let me try printing that out. So you would expect a 2.0. That's right, we have a 2.0 here. So let's try another one. This is called maths.nextup. Val next value is equal to math.nextup. So let's try 10.0. This time I'd like you to guess what would happen. After you made your guess, resume the video. Let me try running that now. If you would have guessed, it would have made it to increment for the next given value. So since we're dealing with a double here what we've done is we have something called decrement exact, which means it would step up by 1, exactly 1. What happens here is next up, it gives you the next possible value that the compiler feels is the next value for a double. In this case, it's just an increment of 2 with whatever decimal place that is. So let me just copy that again and try entering it here. Let's see what happens. It seems like it's being stepping up 2 with whatever decimal places it has. Our assumption is right, it is being incrementing by 2. So similarly, let's try next down. We would estimate, let's just try 10 and see what happens. As you would have guessed, it again step things by 2. And then we have a value with a few decimal places and then an 8 at the end, which signifies that if you would have added this back to this value here, you would probably get 10. So that's it for the basic math functions, which I found useful, and I hope it helped you too.